We're Facet, and we've been solving fuel handling problems all over the world for more than 50 years. Our job is to help you do your job. We know how important clean, dry fuel is to your operation, and that's what this video is all about. Before jet fuel ever reaches the aircraft, there are many opportunities for it to become contaminated. It may be transported by tankers, barges, rail, truck or pipeline. It may be stored in several different terminals along the way, and it will reach the aircraft through a refueling nozzle, refueler truck or dispenser. At each step, even when everyone has done their job and taken precautionary measures, contamination can occur, and that can cause serious problems. Contaminants can appear in the fuel as water, solids, surfactants, and microorganisms. Water can be found in two different forms, dissolved or free. Dissolved water poses no problem as long as it remains in solution with the fuel. Free water is usually in the form of very fine droplets suspended in the fuel. It can cause the fuel to appear hazy, which may come and go as the temperature changes. Free water can also collect at the bottom during shippage or storage. This water is known as water slugs. Solid contaminants can enter from rust and corrosion of the transportation and storage systems, or as dirt and sand particles from tank air vents and piping. Surfactants are considered a major contaminant, not because of what they are, but because of what they do. These detergent-like compounds can make the coalescer totally ineffective, causing water and solids to remain in suspension. Surfactants may enter naturally in the feedstock, related to trailback from delivery methods or from the refining process. Additives like anti-static and anti-icing agents, corrosion inhibitors and other materials can also act as surfactants. Microorganisms such as bacteria, slime and fungi grow only in the presence of water. They're commonly found at the interface between water and fuel. If they're allowed to grow, they can cause corrosion, clogged filters, and create problems with gauges and probes. So it's really very simple. There's a goal, there's a problem, and there's a solution. The organization that writes the specifications and witnesses the testing of filters, filter separators and monitors used in jet fuel applications is the Energy Institute, London, UK. Aviation fuel handling procedures, including filtration, fall within the guidelines of ATA 103 in the US, and for operations outside the US, JIG, Joint Inspection Group, and IATA, International Air Transport Association. Aviation fuel specifications are controlled by the ASTM, American Society of Testing and Materials, at Ministry of Defense Standard 9191. EI publishes Handbook 1550 for guidance on topics related to aviation fueling. The Energy Institute specification for filter separators is EI 1581. This specification has three categories: S for locations where dirt and water may be expected, and SLW and SM for applications where less water and solids may be expected, such as into plane fueling. EI specification 1582 covers similarity, which allows qualification of existing vessels to current specifications by showing conformance with the tested vessel. EI specification 1583 governs the test protocol for water-absorbing monitor vessels and elements. EI specification 1590 relates to pre-filters or microfilters for use with aviation fuels. Facet has a complete line of coalescers and separators, pre-filters and monitors that meet or exceed Energy Institute guidelines. The backbone of any quality filtration system is the filter separator. It separates undissolved free water from fuel. It also removes solid contaminants. As the fuel and water mixture passes through a coalescer cartridge, the small free water droplets gather or coalesce into larger drops. These larger drops will either fall by gravity into a collection sump or are stripped by the separator cartridges. That's why it's called a two-stage separator, because first a product passes from inside to out on the coalescer elements, and then from outside to in on the separator elements. High-quality two-stage separators should be installed at all fuel transfer points and piped so that all fuel passes through them. These filter separators should be rated at a flow equal to or exceeding the highest delivery limits expected from the system. They should meet the requirements of EI 1581 and 1582 and have the proper nameplates and supporting documentation. Before we show you how to clean and maintain your separator, it will help if you are familiar with some of the standard design features. Swing bolt closures allow for quick access and ease of maintenance of the elements. A head-lifting device makes it easier to open and close the vessel. Permanent markings identify nozzle and drain connections to ensure proper installation. Adjustable spider supports help stabilize the elements against vibration and provide bonding to the vessel. Knife-edge cartridge mounting seals eliminate the possibility of bypass. And with sampling and pressure taps, you'll be able to sample influent and effluent product quality. There are also accessory items you should be familiar with. This air eliminator with check valve eliminates air during filling and prevents air from re-entering the vessel during operation. This pressure relief valve ensures that the maximum pressure of the housing is never exceeded. Each housing is fitted with two manual drain valves. One is for draining accumulated water from the vessel, while the other is a product drain valve that allows product drainage from the housing and inlet and outlet chambers. This water defense system can automatically stop the flow of fuel if excessive water is detected. It's triggered by either a pilot-operated float or an electronic probe. In cold climates, you might come across heater thermostats on the water sump and drain lines. And this direct reading pressure gauge is certainly one of the primary accessories. Its readings help you determine the condition of the cartridge and the remaining life of the elements. Okay, let's get to the maintenance info. Begin with following your company's recommendations for use of personal protective equipment. First, handle the cartridges by the end caps without touching the filter media with your bare hands. Always wear gloves, because the natural oils on your skin will cause it to malfunction. Facet recommends disposable surgical gloves. The first step for routine cleaning or cartridge replacement is to isolate the vessel. Relieve the system pressure and completely drain the vessel. Loosen the swing bolts and release the cover. For vertical housings, raise it and swing it clear so you can remove the elements. Horizontal vessels are equipped with hinges. Check the inside of the housing for dirt, bacterial growth and any other contamination. Now, remove the spider, hex nuts, lock washers, gasket washers and end caps from the center rods. Remove the elements, pulling the coalescers first. Be careful not to shake loose any of the sediment. Wipe all the interior surfaces with a lint-free cloth. Check the housings, epoxy lining, and repair any damaged areas with an approved repair kit. Remove the inlet chamber, clean out, cover, and wipe the area inside until clean. Clean all hardware before you reinstall the elements. Some housings will contain synthetic or Teflon separator cartridges. Both types need to be cleaned and reinstalled. First, inspect the filter elements for cuts or damage to the synthetic or Teflon screen. Facet recommends that any cartridge with a cut, nick or tear larger than 1/8 of an inch be replaced rather than repaired. Now, rinse the element thoroughly in clean jet fuel to remove surface contamination. Use a soft brush or gentle back and forth action. If the element can't be completely cleaned of debris, replace it. While the element is still fuel wet, each used cartridge must be tested for its ability to repel water. Hold the cartridge horizontally. Drip clean water on it from a height of no more than 3 inches. As you rotate the cartridge, water should bead and roll off the properly cleaned element. Now you're ready to reinstall the elements. Start with the separators. Remember to wear clean gloves. Add the coalescer elements. Reinstall all end yokes, gasket washers, lock washers and hex nuts. Tighten elements to the recommended torque values. With the cover gaskets in place, carefully close the cover. Secure the closure to the proper torque value using a star pattern to tighten. Replace any accessories that you might have removed. update the cartridge change date and complete all filter records. Now you're ready to slowly refill the housing. Leave the automatic air eliminator or vent valve open during filling. Without any leaks, you should be clean and back online. The filter separator has other maintenance needs in addition to changing or cleaning the cartridge. The following items should be checked on a scheduled basis. Inspect the differential pressure gauge for restrictions and proper operation. The sump float or probe should be checked to make sure it's detecting water buildup. The water slug valve should automatically stop flow if the float signals an excess of water. The pressure relief valve and air eliminator should be removed periodically and tested. Repair or replace any leaking drain and sample valves. And before cold weather hits, you should activate and check sump heaters. Continue to check them during the winter. All filter separators aren't vertical. We performed a change-out on a horizontal style vessel. Both styles utilize coalescer and separator cartridges, and not surprisingly, their maintenance requirements and procedures are very similar. On some systems, you'll find a micronic pre-filter located before the filter separator. This pre-filter is specifically designed to remove dirt, rust, pipe scale, sand, and metal particles. It's placed upstream to protect the filter separator from high quantities of solid contaminants. Different filter media and micron ratings are available. At the airport, these filters must conform with EI 1590, including proper decals and certification. Maintenance and change-out procedures are the same as the filter separator we just talked about. This is a clay treater. It's used to combat the surfactants found in jet fuel. Without treatment, surfactants will accumulate and reduce the water coalescing efficiency of the filter separator. So, like the micronic pre-filter, the clay treater is placed upstream to protect the filter separator. Clay treatment removes the surfactant compounds, color, and additives and can be used to improve the JEFTOT, Jet Fuel Thermal Oxidation Tester value. The key to the success of these treaters are the elements of highest grade attapulgous clay. This clay is like a very fine sand, with each granule having hundreds of tiny fiber-like crystals that capture molecular surfactants. Each pound of attapulgous clay has over 13 acres of surface area. Since the treater housing has no internal moving parts, maintenance and cartridge replacement are fairly simple. Clay cartridges come in either canisters or bags. Each contains nearly 16 pounds of clay. Drain the vessel and relieve the system. Open the cover and remove the hardware that holds the cartridges. Remove the used cartridges. Clean the housing and mounting hardware thoroughly. Load the new clay cartridges, seal it up, and the job's done. There are basic field tests that help you take the guesswork out of when to replace your filter cartridges. The first is membrane field testing. This involves a 1-gallon sampling of fuel through a submicronic membrane. When you compare the color and particulate accumulation against a standard ASTM guide, you'll know the condition of the vessel and elements. To determine the solids concentration, you can perform a gravimetric weight test of each membrane. The microsepometer, or MSEP test, is a measure of the surfactants in fuel and the ease with which water may be released from it. The differential pressure across the cartridge will also show cartridge condition. A corrected pressure differential of 15 pounds indicates the cartridges are plugged and must be changed. In the AquaGlow test, you sample fuel through an absorbent filter pad and subject it to an ultraviolet light source. Water will cause the dye on the pad to fluoresce in proportion to the concentration. The white bucket test is used for filter separators only. Fuel and water are drained into a white porcelain bucket. The liquid is then checked for contaminants. In the clear and bright test, fuel samples are taken in a glass jar or beaker and checked for brightness and clarity. Detailed descriptions and recommended procedures for each of these tests can be found in the ASTM manual. You need to be familiar with several other products. The first is water absorptive monitor cartridges. These come in a variety of diameters and lengths. They also absorb free and emulsified water, remove ultrafine solids, and can virtually shut down system to less than 1% rate of flow when hit with a water slug. In the last few minutes, we've given you information and maintenance tips on many aspects of aviation fuel filtration. We outlined the tests you can do to determine how a particular cartridge is performing and showed you some other products you might see in the field. If you have questions about any of the products or procedures we've described, check with your Facet representative. With proper maintenance and routine testing, your high-quality Facet products will do their job time after time. And that's important because we know a lot of people are depending on the clean, dry fuel you provide. That's why you depend on us, and we'd like to say thanks.